Hello, this is Friday. Oh, Friday, that's good. January 22nd. This is the second lecture of ECE 637, Digital Image Processing 1. It's kind of interesting because I'm not sure there's really a Digital Image Processing 2 anymore, but whatever. So, today we're going to start doing the technical material, and I also kind of thought, just from the point of view of inspiration, that I would maybe go on the computer a little bit and show you how you deal with compiling code and getting it, downloading it from GitHub, running Git a little bit. I mean, I think I'll maybe do this more than once because I feel like you need to get exposed to it in ways. Some of you, it may be like old hat stuff, so I apologize for people who already know that. But you know what? There's a lot of things we're going to cover in this class. Covers a diverse array of topics, this class, so that there's always going to be people who know certain topics, and I guess that's fine because those people can relax during those periods. For the other people, it's more stressful because they have to learn something they're very unfamiliar with. But in the end, you'll all kind of come up to speed on similar things. I did get a question about, I think it was programming in C. And, I have to enable the Piazza page. I didn't quite get to that. I have two classes, so I got one started, and then the other one I haven't. So I have to remember to do that. If someone sends me a reminder, that's great. But but programming C. So the way that it works in this class, I think I mentioned probably, is that I give you a template program. In fact, that's what I'm going to show you today. And then it's kind of learn by doing, okay? Which, frankly, has become more the culture of programming in the last decade anyway. It used to be, when I was a graduate student, if I wanted to learn how to program in a programming language, I would buy a book at the bookstore that, was the official guide to that language. Like Kernahan and Ritchie was the standard book for C. And you'd read it from beginning to end, and then you'd go and try to program. But that's not a really effective way, as I'm sure you know, to learn to program these days. Most languages, particularly languages like Python, you just kind of sort of dive in. And then what happens is you run into problems. I'm sure you guys know this, okay, but I'll say it anyway. You just Google it, okay? So something goes wrong, you just drop the error message into Google. And then, there's somebody out there who's answered your question usually. There's standard places like Stack Exchange, but then it just appears all over the place. So part of the good thing about that is it's kind of easy to fix things. The bad thing is that there's less standardization. So everybody's going to have their own custom environment, more or less, on their computers, their laptop, whatever kind of computer they're using. And I can't give you detailed information on how to configure each machine, okay? To some degree, you're going to have to kind of wing it a bit, which is why I think I'm talking about this a little early now. Because you can go off like this weekend when you have some time, and you can make sure, sort of poke around with, pick whatever computer you're going to use. If you're going to use, how many people here have Apple laptops? Not a huge number. There was a point when almost everybody had one. How many people have Windows laptops? Okay, that's kind of the dominant platform, I guess. So, okay. And how many people have Linux with computers? Okay, good. The hardy few that will keep the world turning. Windows, okay, I'm sorry, okay? I don't know what to tell you, okay? I apologize. I apologize for the fact that, A, I don't know much about Windows, okay? B, I apologize that you have to use it. It's a little bit, you have to kind of deal with it. So I think you get a free license for Windows, what is it called? Microsoft Studio Developer through Purdue, is that correct? Can anybody either confirm or deny that statement? Does anybody know? Okay, but see, you're a Linux user, so of course you wouldn't know. Okay, you're like me. Okay, so is there anybody who uses Windows that knows? Yeah?
I assume you're talking about Visual Studio.
Oh, yeah, yeah. What is it called? Visual? No, what is it called? I can't remember. Visual Studio, it's called?
You can also use Windows Subsystem for Linux and Windows 10.
Okay, what is it called?
Windows Subsystem for Linux.
You see, I know nothing about this. That sounds better though. But there's a thing. I thought it was called Windows Studio Developer, or there's not a thing called Windows Studio Developer. Yeah, I think there is such a thing. It's probably more expensive than anybody wants to pay for. Maybe I'm wrong though, like I said. But the point is, you need a compiler. Okay, everybody needs, a C compiler. You can also download GCC, which is the GNU compiler. But then, if you're on Windows, you need what's called a bash environment, okay? So we'll talk about that a little bit today. I just want to touch on it, at least to get you thinking about it. So we'll try to assemble some resources online for how to go about doing these things. But maybe you kind of look around a little bit. But basically, you need an ANSI C compiler, which GCC is. I think I'd probably recommend that people just use GCC because GCC is freely available. Yep.
I noticed at the first lab there's an example code that's written in C.
There is sample code.
For the rest of the labs, will we be primarily writing our own code?
Well, yes. In fact, for the first lab, you primarily that C code just provides. I'm going to go over that in just a minute. But that C code just provides some basic tools. Well, it does two things, okay? It provides some basic tools for you to read and write images and to allocate memory and things like that, which you'll need to be able to do when you write C code. But the other thing is it just gives you a simple example of some C code that operates on an image. So I think, as most people know, it's a lot easier if you start from a simple example and modify it. So for the first lab, you're supposed to implement a filter. And basically, you take that C code and make some, fairly logical, obvious modifications to it, okay? You have to add a for loop to go through and do the filtering operation. So, it's kind of learn by doing. For the future labs, some of them are in C. Some of them are in MATLAB, but I'm telling you, you can use Python, and we're going to try to convert them to Python. But that's kind of an ongoing process. So you can do them in MATLAB or Python. It's up to you. And the ones that are in C, you can also use this template that we gave you as sort of a basis, a jump-off point, you might say. But the things you're supposed to actually do are quite different than what is done in that C code.
Is it okay to use C++ instead of C?
Absolutely, yeah, that's fine. But we just use C. And C will compile with the C++ compiler. Like the GCC compiler is a C++ compiler. So, all right. Any questions? And then, so yeah.
Why don't we just use MATLAB? So is there any function the C does with MATLAB?
Yeah. Okay. There's two questions really. I'm going to interpret. Your question's an excellent one. I appreciate it. But they're really two questions. I'm going to fold this down since I'm not really using it quite yet. One is why use C instead of MATLAB, and the other one is why use C instead of Python.
What are the functions that C has?
Yeah. Well, yeah. What's the functionality? I guess I would put. Yeah. That's an excellent question. Okay. So the thing is that C we'll learn about. C allows essentially direct access to the computing resources. Okay. So you can have much finer grain control of how memory is allocated and managed, and how computing operations occur in the CPU. A modern CPU is very sophisticated, right? So you really never know exactly what it's doing unless you're really an expert and you know that particular architecture, okay? But still, C is much closer to the actual hardware than MATLAB. And so consequently, if you do a for loop in MATLAB, for example, and you do a for loop in C, the for loop in C will execute like 1,000 times faster. Okay, so that's the fundamental difference. And for what we do in this class, image processing, at least for the foreseeable future, computation is really important. Okay, so in sort of the modern world of point and click, imagine this is a cell phone. You know, you go like this and like that, and it's it's all good, right? Except for that's fine when you're a user, okay? But if you're a developer, that's not good enough, okay? Because you don't really know what's going on, okay? And the difference between something being 1,000 times faster or even twice as fast is the difference between success and failure, okay? And, you know, if someone hires you, they want to be successful. They don't want to fail, okay? So it's not good enough to just say, well, I don't know C, and it's too hard, okay? They're going to be like, well, thank you very much, but we don't really want you as an employee, okay? So the thing is that you need to actually understand what's going on in the computer, okay? And you don't really know exactly what's going on in the computer because, like I said, the computer is just unbelievably complicated, okay? But you do have a rough idea of what's going on. And to the extent you understand that, it makes an enormous difference in the performance and the resource usage of a program, okay? So if you're writing an application for a cell phone for somebody to go like this, you know, you can only use a fraction of the resources in that phone because most of those resources have to go to a lot of other stuff, okay? So your algorithms have to run efficiently, okay? So same thing on a computer. Or even if you're doing something where you're writing a piece of code that's going to run on a Department of Energy supercomputer at Los Alamos, right? And use up an entire $500 million machine for a day. Okay, it better be using those resources efficiently. Okay, or you're wasting somebody's money, like large quantities of money are being wasted. So understanding what the computer does is really important. You know, a modern operating system hides that from users, and that's a good thing. You know, they take the little icon and they move it around here and there, and they click on things and stuff happens, okay? But you're being paid to be experts, okay? So you need to understand what's going on under the hood, okay? So the answer, I think, to your question is that, first of all, C can be way more efficient, okay, and that it allows you to really understand what's going on the hood. Now, I want to also say that, in fairness, something like C or Python, for certain applications, can be much more efficient than C in the following sense: that application is written and somebody puts a huge amount of effort into it. There's a big team that writes a highly optimized operation. You call that one operation, and then it runs very efficiently. It may actually exploit the multi-core processing or the GPU in your machine, right? So at a high level, those languages are great for using. For example, later in the course, we'll be doing a little bit of deep learning stuff, and you use a thing called TensorFlow. So that's all in Python, and it runs very efficiently on GPUs because under the hood, it's running C, okay? The Python's just an interface to code that's highly optimized in C by somebody else. So it's like, you know, you're driving your car, and you have very simple controls. You have like a steering wheel. If you're in my car, it has a clutch and a shift, but, you know, it may have an automatic transmission or whatever. And then, you know, it's a very simple, but what's actually happening inside of the car is very sophisticated, right? All the optimization of the combustion and the computational fluid dynamics for the flow and so forth. But you don't worry about that. You just have the interface. So MATLAB and Python are good for interfaces, but not necessarily so good for highly optimized code. All right, and that's why we're going to learn both things in this class. Okay, the but now then the distinction between MATLAB and Python, that's a little different. Okay, because they play kind of similar roles, and I have my own opinions. Other people may have their opinions. Okay, so I'll put a little asterisk. It's my opinion. That Python is more the way things are going. Sorry, MathWorks. I hope you don't come and sue me. Okay, that Python's the more way it's going because it's open source, which means that everybody can see what and modify and improve things. Okay, and it's from a syntactic point of view more sophisticated. It doesn't have problem. The MATLAB has some serious limitations with the thing called namespace pollution, right? So basically, packages conflict with each other. Okay, and whereas Python has designed into it because it's a more modern language. I mean, MATLAB, the language was defined in the early '80s. Okay, so obviously Python has an advantage. They try to update it, but there's always legacy issues. Maybe that was more information than you wanted. Anyway, but did I answer your question?
Yeah.
Okay, yeah.
So how much difference is there between C and C++ in terms of computational?
Oh, I'm sorry, say that again?
How much difference is there between C and C++ in terms of computationality?
C++ is object-oriented C, and I'm not an expert in C++, so I am a little hesitant to go too deep into this because I'll say something that's wrong. But the difference between C++ and C is that it's more structured, so you can write code that's more maintainable. Okay, and that's a great thing. But if you use some of the more sophisticated features of C++, you may lose some efficiency. But then again, if you want the maximum efficiency, people will actually write stuff in assembly language. Okay, so there's always a trade-off between human time and computers' resources, and so the trick is to allocate your time where it pays the biggest payoff. So this is a little philosophical, but when you have a complicated piece of code, usually what happens is especially for this kind of image processing stuff that we do in this class, there'll be some kernel operation which requires most of the computation. That little kernel has to be highly optimized, okay? And then the interface, well, that can be very inefficient because the interface is more about sophistication, and the human time is much more valuable than the computer time in that case. The computer should do our work for us, but for those core operations that are typically very mathematical, those things are the things that you want to optimize. So like filtering is a good example. Okay, so that's kind of the philosophy of. So there's not maybe part of the takeaway here is that there's not a silver bullet. There's not one answer to everything. You need different answers for different parts of the problem. And that part of what you should learn in this class is how that breaks down, right? So you understand what the different tools are and how they play a role for the different parts of the problem, okay? So maybe I can switch over the computer. I've never actually used a laptop before in this class myself. I've plugged it into HDMI. So this is, hold on, I have to plug it in here. That's a good point. Plugging it in is the first thing you learn as an electrical engineer. There you go. Does it work now? It works. I'm shocked. Okay, so this is the class webpage, right? And then I can go over to, I haven't enabled Piazza. I'm sorry, it just slipped my mind. But I'll go to laboratories. These are the laboratories. And if I go to the first laboratory, it's here. And there's a laboratory procedure. But if I click on this thing here, it takes me to this thing called GitHub, okay, with this code, okay? And what I'm going to do, okay, but this is the part that's going to be shocking. This is a real, okay, I don't know. I'm sorry. I'm probably highly biased because I grew up as in went to school, graduate school. That's essentially your intellectual growing up, is in the 80s. So, but to me, this is a real computer, okay? When you interface it, how many people are used to using like terminals and bash shells and that kind of thing? How many people feel this is like an uncomfortable way of dealing with the computer? You can, okay. Well, you can actually fall into both categories, okay? Okay, so, which is perfectly fine, okay? You know, don't feel bad, okay? But yes, Bash is what they call the shell, okay? It's sort of the way you interact with a Unix computer. Linux is basically a variant on Unix, and the Mac is the Apple. The reason I buy Macs, they're a little overpriced, honestly, but the reason I buy them is because they give you sort of like the standard Microsoft Office environment that you're used to, but they also are Unix under the hood, okay? So now the problem, though, with a Mac is that it doesn't come with a compiler. I don't know why. I guess they want to protect you from that knowledge or something. So so you have to install the compiler. So to install the compiler, you have to go, I think, Google. Okay, so this is an example. Okay, hopefully nothing bad will come up when I'm Googling. Okay. So you would be something like install Xcode. Now, and I have no idea what I'm doing here, so this is just winging it. My point is this, that you can come down here and just say, how do I download Xcode and install it on your Mac? And hopefully, and amazingly enough, this is a great way of solving problems. So it'll basically tell you how to do it here. There's a place you go. Actually, you can install it with let's see. Wow. What's it doing here? Your Apple ID is being used. New ways. Okay. Okay. Oh, how come it didn't do it? Hold on. I want to try to actually do this because it looked like it would work. Oh, I see. I go here. Allow.
You have to like verify through your phone or something.
Oh. Hold on.
It's like I'm giving you the verification code.
My phone is
No,
going.
it's right here. It's on your screen too.
Oh, it's on my screen too?
Code.
Where is it?
150007.
Oh, okay. I could just type it in.
Yeah.
1500. Thank goodness we have some people who know what they're doing here. 7. Done. Trust. Oh, see? Now, you may not have a Mac, okay? But I just want to point out, then here what you can do is, now you couldn't do it through this like special gee whiz point and click thing, okay? But it's better to do it this way. It actually works better. You can click here, and then you can, I already have it, but you can download it. When I downloaded it, it took all night. I have no idea why, okay? But sometimes it takes a little while. And you need to get this, but you also need to get the command tools. You basically have to follow the instructions, and the instructions change like every few weeks, okay? So, you know, I don't know what to tell you. But, so that's good. And if you have Windows, it's a little more complicated, okay? But I'll try to find some instructions on Windows for you. I have it posted somewhere. And Linux, okay, then you're good, okay? The Linux, this is the one time, normally the Linux people are always suffering because they're like the people who can't open the PowerPoint files up and everything. But this is the time when they shine and they make everybody else, you know, look bad, basically. So the Linux people can smile. Okay, so you install those things, okay? And now I also got this thing for my Mac. It's called Terminal 2. It's a little unfair. I feel like I'm giving too much advantage to the Mac people. But if you have an Apple, you can, and that's a better terminal than it comes with default because you can cut and paste into it, okay? So this is my environment. This is my root directory. PWD tells, oh, so you can install this bash interface on like a Windows machine, and then you'll get basically the same functionality. It's not quite as, it doesn't have every bell and whistle, but it'll have most of the basic stuff that you would use. And then PWD, you can see the directory structure, okay? everybody understands that computers have the directory structure, right? There's the root directory, which is the top of the file system, and then you move down through a tree, okay? So your files are located in there. You need to get used to this. This is like all hidden from you when you use like a tablet, like an iPad. Oh my God. I dislike iPads, okay? Because you can't see the file system, okay? So I'm going to CD into documents because I know that's where I have, and I have here a thing, GitHub. So GitHub, that's where I keep all my GitHub stuff, okay? So I'm going to do, okay, the C code's already there if you notice, right? Let me make the font bigger. I hope I'm not accidentally going to do something which is going to allow somebody to hack into my computers. Okay, this is a little dangerous, but hey, it's all for the public, the greater good. So, okay, so C code's there, but I want to get rid of it so I can have the same experience as you'll have. So, /bin remove. The reason I do /bin remove is that the remove function is in /bin, and I bypass the alias that way. And then -r means it's going to do a recursive deletion of C code. And so I go like this. Oops, okay, I forgot to do something. Control C. Control C. Because I forgot, it's going to keep asking me questions. The beauty of Unix is that it has a function for everything. So it has a little function which answers yes to every question. Okay, it's sort of the opposite of a Purdue administrator, because they would answer no to every question. But I'm sure there's a no in here too. Okay, but that little straight line is called a pipe. Okay, so it pipes the output of yes into the thing that's going to ask the questions. I hit that, and it deletes the whole thing. So now it's gone. Just to prove that actually that thing is there, I could go to Documents, GitHub. So this is like the normal browser that you would be used to, except I have it set up so it's listing things out in lines because it's easier to see. And you can see that it's not there, okay? But the beauty, I like this because here I can really see what I'm doing. I'm in total control, okay? Maybe I'm funny about that. Like I said, I have, well, okay. Yeah, it depends on how you count. But I have 2 cars that have manual transmissions, okay? I like to shift myself because that way I know exactly what gear I'm in all the time, okay? And this is a little bit like that. I know manual transmissions are going away. But, so let's say GitHub. Okay, so now I want to copy the thing over, okay? So I go over here. Oh, first of all, you need Git installed, okay? There's a thing called Git. So if I type Git version, that's the version of Git I have. I could probably update that, actually. And on a Mac, there's a thing called package control. So there's a thing on the Mac called Brew or Homebrew. Update Git. I think that would actually work. No, it wasn't happy. Okay, I'll do that some other time. But Git 2.29 is fine. So you need Git, okay? So you're going to install that. And you'd say, well, what does Git stand for? If you look it up on Wikipedia, Git just means like jerk, okay? So the guy who wrote Git is the same person who wrote Linux. Is Linus Torvald, who I've never met, but must be a genius. And he wrote it over a weekend. He was in a bad mood, I guess, because, and so he decided, so he called it Git, okay? I don't know. And then they have this thing called GitHub. So if you want to get this thing, there's a bunch of commands in Git, okay? And we're going to talk about that. So you type Git and then clone, okay? Because we're going to clone this. And then I copied the URL up here. I'm doing, flower C on a Mac. And I copy it here, okay? And I hit return. And it should, oh, thank goodness it worked. It would have been embarrassing if it didn't. And it copied it. So now C code's cloned over there. Now, the beauty of Git is it allows you to, now you don't have access to this repository, but I do. So it allows you to change things, okay? Like for example, maybe I'll change something silly just as an example. So this is like the README file, right? So I can CD is change directory, C into C code, okay? And I'll type README. And okay, so I'll just scroll down, and I'm going to do something. Oops. Control down. Oh, there it goes. Okay. I'm going to do something silly. I'm going to just add like an extra line feed at the end. Okay. This is, by the way, VI that I'm using, which is only ancient people use. But I learned it years ago, and now I'm stuck. Okay. But you can use some other editor, but you have to make sure that it's an editor that you can't use Microsoft Word to edit this file because you will screw it up. Okay. Why? Because this file is ASCII. How many people know what ASCII is? Okay, ASCII is this. There's a standards body that's defined a mapping between 8-bit binary words, okay, 8-bit bytes, and the letters of the alphabet. They don't really need, so if you have 8 bits, right, which is the standard unit of information stored in a computer, you have 8 bits, that's 2 to the 8th is 256. We're going to learn about that because we're going to use it a lot in images, okay? So 256. But there's only, what? How many characters are there in the English alphabet? There's it's 32, right? No. 26. Oh, my gosh. Okay. 26, okay? 26 letters in the alphabet. Now, you need upper and lower case, right? So that's what? 52. But then you also have things like periods and line feeds and spaces. So by the time you're finished, you have about 127. So they only really use 127, which is 7 out of the 8 bits. The 8th bit they don't really use, okay, in ASCII, but it's kind of wasted, okay. But nonetheless, so the point is this: if you use Microsoft Word, it's going to encode some crazy thing. Yeah, you'll read it. But the computer only cares about the ASCII values, okay? So you don't want to use a word processing program. It'll screw up the file. You want to use, I use VI, okay, or Vim. It's the same thing. Or some people use Emacs. Or you can use a special editor designed for editing code that will maintain only ASCII, okay? But that's very important. So this is part of actually understanding what's going on in the computer. So now here I can write it. Okay. So now, oops. Oh, what am I doing? Oh, escape. Okay. So I changed it now. So I changed that thing a little bit. Now if I say get status, it knows I've changed README. Okay. So now, if I want to update the Git on the website, what I can do then is this. I can, I feel like maybe I'll do a little bit more. Hold on, VI. So you can actually see. This is a test. Okay. So now I've added the words, this is a test to the end of the thing, right? And so I type get status again. Come on. And you can see it shows I've modified it. Now what I do is I say get add, I'll say get add readme, okay? And I'm adding this to, it's called staging. Okay, I know this is not going to make a huge amount of sense, but I'm going to do it anyway, just so you can start getting exposed to it. And then what you do is you do git commit. Oh, now I'll do git status again. And now it's green. It's modified, but it's staged. Okay? By staged, it means it's put it in a queue of things that it's going to update to the Git site. Okay? Then what happens is that, then what I do is I say git commit. Oh, now this is going to be dangerous. I hope that there's not going to be a thing where it won't. Okay, I'll try. Minus M. And I give it a thing. I test example for students. And what that says is I've committed that change. When I hit return, I will have committed that change as an example for the students, right? By committed, this is the beauty of Git, okay? It's actually almost mind-boggling that every change you ever make is committed for all eternity. The beauty of that is you can never destroy anything. And the bad thing is you can never hide your errors, okay? So for all eternity, if I do something stupid, it will be there for everybody to see. Git keeps a complete, unabridged history of everything you've ever done. So you can always roll back to any point, okay? It's really powerful that way. So I hit return. Okay, now I say git status. Now the thing is this. Now it's committed locally on my laptop, but it's not actually at the site. Because in fact, I could reload this page and it's not there, okay? So if I want to put it on the site, I have to do git push. Let's see if it actually works. Oh, it does work. I was a little worried that it was going to ask me for a password and there was going to be some kind of problem. Now, if I reload the page, let's see if this actually works. It should work. Hold on. It's going to make a liar of me. This is a test. You see this? Okay? So that's what's called a revision control system. Okay? So we're going to, now I can change it back. Well, I won't change it back. But anyway, so the point is this. Now, I'm going to actually teach you a little bit more about how this works. Not that you'll be experts, but maybe, and I would encourage you, this is how you should do your software. Any software you write, you should write, Git's free, okay? Now, I think it's only free if it's public, but who cares? I mean, you're going to write your thing. I don't think anybody's going to. I mean, maybe you care. I don't know. You could pay the small amount of money and then have, or you can set up your own Git server, okay? But it's basically free. And this, whenever you're working on a piece of software, it gives you a complete history of the software changes. So if at some time you screw up the software and you need to roll back to an earlier version, you can always do it. It also allows multiple people to collaborate, okay? So multiple people can be making changes at the same time. Yes?
You can make your Git repository private. Some classes require it to be private.
Oh, okay. Yes, you can, but it has to be a Git. You can set up a Purdue Git. Yes. Any Purdue student can set up a Git account that's essentially a paid account for free. In other words, and then they can be private. Now, my own Git is like my own. I'd rather not be. Actually, Purdue had, they had their Purdue Git thing. Didn't it like do some weird thing where it crashed recently? Okay, but anyway, you can get a free Git account through Purdue. That's the deal, okay? Or you can set it up yourself under your own email address. You don't have to, but it really does make life easier, okay? And that's one of the things I want to teach. So, here's the thing that I want to do next. Now, inside of here, I'm trying, I just, one thing that I noticed is that, like when you go to dinner, right, with somebody, and you go to an expensive restaurant by, they're trying to recruit you to take a high-powered job. And if you like grab the knife and the fork and you started shoveling the food in your mouth, okay, it would look bad because it's not considered proper etiquette, okay? Now, there's nothing wrong with it, I guess, okay? And it's kind of all an artifact of social convention, but still, maybe it's not a good idea to just shovel the food in your mouth, like, and slop it all over your face, okay? It's called bad manners, okay? I'm not trying to judge, okay? So there's a similar things with computing. There's all kinds of things you can do, but some of them are considered not tasteful, okay? Okay? So there's certain conventions you follow, and it's just considered a little more sophisticated, like that you know what you're doing, okay? And I don't pretend to be a total expert or anything, but there's at least, and you know, sometimes people can get a little carried away, but it makes sense. So for example, SRC, that's a standard designation you have for a folder, a directory that contains source code. Okay, source code means C, Python, Fortran, whatever. Okay, so if you go in here, you see, oh, and this will be exactly the replica of what's on the directory system here. You can see here's the C code. Okay, and one of these things is a makefile. We're going to talk about that in just a minute. Okay, over here, bin. What does bin mean? Bin means binary. Okay, because binary is sort of the opposite of ASCII, okay? ASCII means you just have coding. You're only using 7 bits out of the 8, and they're actual symbols from the alphabet, like English you can read. Binary means if you try to display a binary file, it'll just look like gobbledygook on the screen, okay? Because those are the things, those are typically the executables that the computer runs when you want to run a program. So that you put those in here. Source code is ASCII. Binaries are the things you run. There's nothing in here right now because we haven't compiled. And then demo, well, that's a non-standard thing, but it's something I like to put there. These are like simple demos you can run because typically it's easier to figure out how to run code when you have a demo that you can do as an example. So let's come back here. I've already installed everything. So here I can say, I go, okay, so I CD into the source directory, right? And now there's a thing called a makefile. Makefiles are very important because makefiles they tell the compiler, really, or the way you communicate with the compiler on how to compile your source code, okay? So this is saying there's a lot of crazy arcane syntax in here. So I won't go through it all, but basically this is telling the computer use a GCC compiler, okay? It's saying these are the flags to set. This is saying to use a standard version of the compiler. Wall means that it's being really particular about warning you so it can make corrections. And pedantic is the same other thing. And then bin just tells you that's the directory I define as bin. And then this is like two programs it's going to compile, okay? And this tells it how to compile, okay? So, and you can learn about that. But basically what happens then, you say make with lowercase m. And when you type make, it knows, use the makefile to compile the code. And there it compiles, right? Now, it wouldn't compile for you until you have the compiler installed properly, and you probably run into some problems. But I tested it before I came here to make sure it would work. Okay, but it usually is pretty robust. Then I CD into demo, and I run more demo. I even forget what's in here. Okay, there's 2 silly little programs in here. Okay. One program converts a file. It does some kind of silly thing, and the other program does some other different silly thing. I think one takes the green component and swaps it with the red or something. And one adds some noise. You can look in it. But the point is I can run those. So, here, notice that there's a star next to the file demo. Why? Because if I type alias ls, I have my function alias to, ls means list. That's how you list out files in the bash shell. And I have it alias to ls minus f. So ls minus s also gives me the type of the file. So the star there means that demo is an executable file. in Windows, executable files have to end in, what is it, .exe or something? But on Unix, anything can be an executable file. And it doesn't necessarily have to be a binary. Demo is not a binary, actually. It's a shell script. If I more it over here, hold on, more. Let me do that again. Hold on, let me see. Oh, the first line there is pound bang / bin bash. Okay, what does that mean? The pound is a comment. In a shell, pound says that this is a comment line. Okay, the bang combined with the pound says run this as a bash shell. There's multiple shells that can run inside of Unix, so you want to make sure that this runs. The syntax is compatible with the shell type. I could be running a different kind of shell. Like there's things like C shells. There's also, I think the most modern thing, which I don't use, is a thing called a Z shell. What is it called? Is it a Z shell? Does anybody know? That's the thing everybody runs these days, but I'm still old, so I'm running a bash. Okay, so I can run this ASCII file. It will run it as a bash. Basically, bash is like a programming language, so it'll run it as bash. So I type dot means the current directory I'm in / demo. Okay, and it just ran it. And it put the output in the output. And there they are. So I can go look at them here. Oh, I don't need this anymore. Documents, GitHub, C code, demo, output, color. That's a TIFF file. And there you go. It created a screwball looking image by swapping, I think, the green and the red or something. Okay. And then here is, text. That was one of the outputs. I even forget what it's for. Let's see what this is. Oh, this is just a noisy image. I added some noise. The beauty of this is that program has a random number generator, which you'll need it from time to time. So my point is here that this is sort of the preferred way of doing programming from my point of view. Okay, from the command line with a standard, say, open source compiler. You don't have to, but that's what I basically recommend. It's worthwhile taking the time to try to configure your machine. I need to give some more instructions to the Windows users because there's standard tools for installing those kinds of things. And this kind of gives you more direct control over what's going on. It allows you to fully understand it. And in the end, that's what people who hire you pay you for. They want you to know what you're doing, okay? So that's kind of that. Are there any questions? For some of you, it may have been very remedial. I don't know. But I think it's important, if for no other reason, just to sort of set the right tone, okay? So is there any other questions? Yeah.
Can we start doing the lab one?
Yes, you can start doing the lab one, except what we may change. I'm working on changes to lab one only in the sense that it currently tells you to do things with MATLAB in terms of displaying the images, but you're really allowed to display them, produce the output. You don't have to use MATLAB. You can use anything you want. And in particular, we're going to convert it over to give instructions on how to do it with Python. Okay, but we're in the process of doing that. But that shouldn't change your ability to produce, a correct lab a correct solution. Right? Yeah.
When you set up the Piazza, I'm willing to put up some instructions on how to set up Windows.
Oh, that's fantastic! I love that. Thank you. Yes. As a matter of fact, that really sets the right tone because that's how modern programming is done in communities. People exchange information. This is really just meant to kind of get you started, but you should talk to each other, and I think Piazza will be a great way to do that. I love it. Okay, I'll do that as soon as I get back to my office in my home. Okay. All right? And I think we're basically out of time. So we can go back and I can say goodbye from the video. Thanks, everyone. It's been fun. And we'll see you on Monday. Take care. Bye.